Good afternoon, YouTube. Welcome back to the channel. Back today with another video. It's been a little bit. It's been a wild week and a half. Unfortunately, had a death in the family, so went through that process of celebrating life and funeral services and whatnot. So that occupied a bunch of my time. It was an impactful experience. But now we are on the other side of that. Of course, we won't ever forget that person, and we'll always feel that. But work life, normal life, family life is sort of stabilizing now. We had some guests in from out of town, and actually a couple are still here. But I found a moment, or actually a little bit this week to study, and I figured I would record another quick lab here. Hopefully it goes quickly, we shall see. This was new to me. I know that time is important, especially on network devices and in computing in general. When it comes to the ability to search for information, searching through logs, and I know that when devices on the same network, have different times, that can really inhibit your ability to find information you need, particularly when it comes to ferreting out and figuring out what happened in a security incident. I've had experiences with that before. NTP, Network Time Protocol, I didn't really know much about it until I started studying this week. And I'm looking forward to this lab for that reason. See if we can get NTP hooked up. And so just reading through what we've got for this one. This is, again, Jeremy IT Lab's Day 37 lab. Routing has been pre-configured, default route on R1. OSPF on all routers with basically reachability throughout all of the subnets. Configure the software clock on R1, R2, and R3 to some particular time. Configure the time zone on each of those. Configure R1 to synchronize to the NTP server. Okay, so that's configured there already. What stratum? Some questions about that. All right, so this is all pretty familiar to me because I've been studying it the last week or so. So I don't see anything that's too spooky. So let's get started. First things first, software clock versus hardware clock. That's a thing. These devices have a software clock that we will access using the clock command, and they have a hardware clock that we can access using the calendar command, which is kind of, I don't know, illogical to my ears, but nonetheless. Another quick note, I've done some thinking about what I want this channel to be and kind of how I want it to evolve. I'm definitely going to keep doing a lot of the programming stuff, a lot of the network configuration stuff. I would like to get into some drone related material, so if that is something you're interested in, please stay tuned. In particular, drone, I love to fly drones and I just love drone technology, but I really would like to go deeper into drone communication protocols and just in communication of computing devices, network devices in general. So expect more of that to come. I'm excited about sort of where this is going and how it's, just getting off the ground clearly. But, double the number of subscribers than we had a month or two ago. So, hey, that's good. I really just find this stuff very interesting. I feel like my career is being gradually and slowly revealed to me. Like, what am I supposed to do with my life? I think I'm supposed to be involved in language and in communication, in particular in and around computing and perhaps securing that communication. That's really sort of the path I feel like I'm on. We shall see. All right, so let's do EN. Let's see what we get for clock. Nothing. Clock question mark. All right, so we've got the ability to set the clock. I'm interested if I can just see the current time. Show clock. All right, good. And how about show clock detail? Some more information. All right, time source is the hardware calendar. That's good. Interestingly, this device is set to 1993. It goes way back. So let's do what it says. Let's get you the ability to view all of that. Configure the software clock. So clock set to some time. I'm going to just do whatever I've got right now. So I've got 0400 basically. What is it? July 8th, 2025. All right, and anything else? Nothing. So I'm going to do that. I am curious if you can just put anything here, or does it actually, what if I say foo tab, foo 8, 2025, what will happen? All right, so it has some intelligence about what it allows you to put there. Will it allow the full word July? Interesting, okay. How about a date in the past? Is it that? Well, no, surely it does a date in the past because it was just 1993. So anyway, so that's some interesting stuff. What should we do for number 2? I think configure the time zone of R1, okay, to match your own. So I'm already on R1, so I figure I'll, can I do it here? What do I do, time zone? Calendar. I feel like I have to go into configuration mode, clock, time zone, there we go. So if I go back, clock, question mark, time zone, the word, Central Standard Time, offset from UTC, I think it's 6 from UTC, and minutes, 0, question mark, nothing, all right. So clock, time zone, all right, that's set. So time zone and clock are set, software clock and hardware time zone are set. Do show clock detail. Time source is user configuration, and notice it now it has the time zone and the date, whereas when we first did this, it was in UTC. Okay, so, and it's noted that we are setting the clock based on user configuration. All right, cool. So router 2 for the next part. Let's do router 2. Come on over. We see some of the logging around OSPF. So if you were here for the last few videos, we did a bunch of OSPF stuff. So near and dear to my heart. EN, show clock. All right, so we're still on UTC. Again, the same thing. Clock set, question mark. Let's see, 04, 04, 00. July 8th, 2025, question mark, no. And then we needed to go to conf T and go to clock, question mark, time zone, CST, offset from UTC is 6 hours, 0 minutes, and that is done. All right, sweet, router number 3. Okay, so EN, show clock, clack. All right, what is time? So show clock, clock set, question mark, 04, 05, 00, July 8th, 2025. Interesting that it only goes up to 2035. That's kind of odd. All right, and then conf T, clock, time zone, CST, offset from UTC is 6 hours, 0 minutes, and that's done. All right, so I think we've got the clock and the time zone set for each one, the software clock. They're all obviously going to be different. Do show clock detail, 10/5/25. Oh, it fast forwarded 6 hours because I said that it was standard time. Okay. Which, interesting. When I set the clock originally, I set it to Central Standard Time, but that's incorrect. So if you're doing this real life, make sure you set UTC and then set your time zone so that it matches what your time zone's time is based on the offset. Because when you do clock set, you're setting UTC time. So now it thinks it's 10 o'clock. Anyway, it doesn't matter. We're basically doing the whole point of this lab is to now all these have individual times. We're going to sync them up to an NTP server, and I think sync them up to R1 as maybe a backup, and then they'll all share the same time generated by the NTP protocol. All right, so configure R1 to synchronize with NTP server 1.1.1.1 over the internet. Just curious if I can do the clock command here. Time, clock, show clock. Oh, is this, let's see, I want to look this up real quick. Windows, how to view time. Windows CMD. /T. What? Command prompt /T using prompt. What is it there? Prompt? Time? Well, I don't know. Let's see. Configure R1 to synchronize with NTP server. Okay, so I think I need to do, I'm in config, so I need to say, first of all, NTP question mark server. So tell it what its NTP server is. And its NTP server in this case is server 1.1.1.1, apparently, according to the directions. All right, what else? Configuration peer, and it doesn't say anything about that yet. So I'm going to press enter and do show clock detail. Hardware calendar. I think it takes a while to sync. I don't know how long. Lots of time maybe. Let's see. I'm going to fast forward us. And then we'll see maybe. There we go. All right, so the time source is now NTP. Actually, let me make this a little bit easier to see. And we are getting information. So let's see if we can see how we're getting information. Question mark. NTP, let's see. Exit out of here. Show NTP, question mark. Associations. All right, so first of all, let's do status. Show NTP status. Our clock is synchronized here on R1, stratum 2. So configure R1 to synchronize to NTP server 111 over the internet. What stratum is 1111? Stratum 1111 is stratum 1 because it's one less than our current. I think that's how it works, or maybe it's stratum 2. Let me do show NTP associations. Yeah, so it looks like stratum server 1111 is stratum 1, and we're like one step removed from that, making us on R1 here stratum 2. All right, so that's interesting. So those are those two answers. Configure R1 as a stratum 8 NTP master, synchronize R2 and R3 to R1 with authentication. The NTP source command is not available in Packet Tracer, so just use the physical interface IP addresses of R1. Okay, so first things first, let's go to conf t NTP question mark. I'm going to say master. So now, as the directions say, we're setting, so R1 is getting its time via NTP from server 1. And R2 and R3 are going to get their time from R1. And the reason this is important is because if R1 loses a connection over the internet here to server 1, the rest of the devices on our private subnets can still maintain sync. They're not impacted by the loss of connectivity between R1 and server 1. So that's why we're configuring it as a backup versus them like reaching all the way through R1 out to server 1. Then they all go down if the connection is lost to the server. All right, so NTP master, what's next? Question mark. 8, I believe, is what we want to do, stratum 8. All right, so it's a NTP master 8. Now we need to go over to R2. All right, let's see. En conf t. All right, so now I want to say NTP server. Now in the case of R2, it's pointing to the .1 interface of R1. So that's 192, let's do a question mark, yep. 192.168.12.1, question mark. All right, and it says to do it with authentication, so we're going to have to create a key, the number of the key 1, and it looks like that is it, question mark. Yeah, that's it, okay. So we tell it what server it has and to use key 1, got that. All right, now we say NTP question mark, authentication key. Oh, and we need to say authenticate, NTP authenticate, question mark. So we tell it to authenticate, and then we do authentication dash key, and we create our key number 1 that will be used in that connection. MD5, which I think is the only option, maybe the default, and I'll say show top for the channel's namesake. And authentication key encryption type. I don't think this is necessary, but I believe MD5 is 8. I could be wrong about that, but let me just go with that. Okay. Cisco, I'll ask Google. What encryption type is MD5 Cisco iOS? Type 5. I'll just go with that. And if anybody's watching this and knows what that is actually supposed to be doing there, authentication key encryption type, because MD5 is, it's in the title, type 5, I don't know. Authentication key number 1, MD5, show top 5. All right. All right, and then NTP question mark. I think we need to do trusted key, and number 1 is a trusted key, and that's done. All right, so now I think R2 should be able to synchronize with R1. And let's do the same thing over on R3. So we're going to say en conf t NTP question mark. Let's say right off the bat here, NTP authenticate. All right, and NTP authentication key 1, MD5, show top 5. Good. Now we need to say NTP server. And in this case, we're on this leg of our journey here. So we're going to 192.168.13.1 for the, I guess, the other interface, the other .1. I shouldn't have said .1 earlier, but anyway, the other .1 interface of R1. NTP server 192.168.13.1. And this requires a key, and it's going to be number 1. All right, we've authenticated. We've set authentication. We've created the key. We did all that. Did we do trusted keys? NTP trusted key 1. NTP trusted key. We set the server. You know what, and actually this is a good thing to do. Do show running config and then where NTP begins. And that can show us like a rundown of the current configuration that we've got going. So, you know what, I bet setting that value for authentication key deals with how it's encrypted on the device. I think that's what happens. Maybe if I didn't do anything, it would just show up right here as Cisco or as Showtop. So NTP authentication key 1, authenticate, trusted key 1, and the server. All right. So that's done. So let's go back to router number 2, and we can do that same little inspection. Do show running config where NTP begins. So authentication key, blah, 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 authenticate, trusted key 1, server key 1, 12.1, etc. All right, so do show clock detail. So time source is hardware calendar. I wonder how long that will take. Let's fast forward a bunch and see if we can get it to actually show that we are synchronized via NTP. All right, and show clock detail. Still hardware calendar. Is that expected? I'm not sure. Let's look at this one, see if it's connected. And show clock detail. So that seems odd. Maybe I'm missing something. Let me fast forward a little bit more. Should be hooked up though. Okay, so that doesn't seem right. Let's go back to this thing. Conf T NTP master as a master clock 8. So that's already done. Now let me do the same thing here. Do show running config begin NTP. So its NTP server is 1111. It's an NTP master. Maybe I need to set it up for authenticate. NTP authenticate. NTP authentication key 1. MD5. Showtop 5. Okay. And NTP trusted key 1. NTP question mark. So then let's look at its configuration again. Do show blah, blah, blah. So it has a authentication set up. It'll authenticate trusted key 1, server master. Okay. So let me try to fast forward a bit again, and let's see if they're synced up now. Sweet. All right, so let's make that a little bit bigger or more clear. So R2 is now hooked up to R1 for its time as its time source. I'm going to say show NTP associations. So it's got an association with 192.168.12.1. All right, and what's its status? And it is stratum 3 because it is one layer away from a stratum 2 server, NTP server. So that's good. Let's do number 3 and make sure that that's hooked up correctly. Show NTP status. It's synchronized. It's also Stratum 3, so that tells us it's a good sign. Associations. It's hooked up to 192.168.13.1, this interface right here, Stratum, which is Stratum 2, making it Stratum 3. So everything looks like it's hooked up correctly. All right, configure NTP to update the hardware calendars of R1, R2, and R3. You can't view the calendar and whatever. So this is just kind of a moot point because we won't be able to actually see. But if we go to conf-t NTP, we can just do update calendar. And that's the command to update the hardware calendar via NTP as well. And so if I do show calendar, yeah, it doesn't in Packet Tracer allow you to do that. So I think that's it. To be very thorough, you'd want to do this on R2 and R1, but it's the same thing, just running this single command. That is it, I think. Short and sweet, a pretty nifty little protocol that keeps all your clocks synchronized to one location. It's kind of interesting. The most trustworthy clocks are like managed by the Navy, the U.S. Navy, I want to say, or maybe there's like some others elsewhere. But I researched that a little bit prior to doing this. A lot of servers, Stratum 1 servers are managed by the U.S. Navy. So if anybody out there is listening to this and you've got some interesting information about that, I'd be curious to learn more. So yeah, that's it. Everybody enjoy the rest of your day, the rest of your week. It's a dreary, rainy day, as you might be able to see behind me here in Missouri, but interesting content here. All right, thank you all and have a wonderful day. Goodbye.